All right, working on the second problem from the dynamics review. We're supposed to look at this situation where you have a ramp, angle theta, you have a block on there, and there's a coefficient of friction, UK, with the block of mass m. It is sliding down the ramp at a constant velocity, and we want to draw the free body diagram for the forces on this block. So, first of all, the weight of the block, mg, points straight down, right? The normal force would act at 90 degrees from the surface, and then friction, since this thing is sliding down the ramp, would be up the ramp, okay? So it would be all our forces here. We want to write an expression for the coefficient of kinetic friction. We want it in terms of m, theta, and g, all right? First thing we need to do is break the components of gravity into their y and x values, right? So if that's theta there, then we're going to have a component for gravity along the x-axis. So pointing this way, this blue arrow here, which is mg in the x direction, and then we're going to have a y component like this, which is going to be mg in the y direction. Okay? So mg in the x direction would be equal to mg times the trig function that represents the opposite side, so it would be the sine of theta. And so mgy would then have to be the cosine. Okay? And so now if you write our expressions for the net force in the x direction, we can take Fk to be the positive one, the force of friction up the ramp, and then we take mgx to be down the ramp, so we would say minus mg sine of theta. And this thing is moving at a constant velocity, so this would be times or equal to 0. Remember, on the right side of this equation would be m times a. A in this case is 0, so 0 acceleration. We can replace Fk with the coefficient of friction times the normal force, minus mg sine theta is equal to 0. Now you think you might be able to solve for the coefficient here, but we still have an Fn in there, and we don't want Fn. It's not one of the three things that we can include in our answer. So we have to look at the y direction. In the y direction, we have the normal force up, and then we have minus mgy, which would be mg cosine of theta. And again, there's no acceleration in this direction, so this would be equal to 0. So now we can solve for Fn here by moving mg to the other side. So this becomes mg cosine theta is equal to 1 normal force. And we can take this value for Fn and plug that in to the equation we have over here, right? So let's do that. So mu k times mg cosine theta minus mg sine theta is equal to 0. Right? So I'm going to have to steal a little bit of space from the next problem. I'm going to move this mg sine theta so that my equation now becomes that the coefficient of friction times mg cosine of theta is equal to mg sine of theta, right? And then I can divide both sides by mg cosine theta. So I'm going to divide by mg cosine theta So that on the left side, all I have left is that coefficient. If I look at this here, my mg cosine theta cancels on the left side, mg cancels on the right side, and all I'm left with is that mu k is equal to this sine over cosine. So you can leave it as that, or even if you know that that's equal to the tangent of theta. That would be the correct value. All right. In C, a second inclined plane identical to the first, except with negligible friction. It's prepared and the same block is placed on the plane. Determine an expression for the exertion of the block on the new incline. So all that's changing now is that if we were to draw our free body diagram, the friction's gone. So we'd still have gravity acting this way, and we'd still have a normal force kind of working at an angle like this. And so we'd still have those same components. We'd still have, mg in the x direction and mg in the y direction. But the only one that works in the x direction out of all the forces we have listed here is mgx, right? So the net force in the x direction is just mgx, which we already said is mg sine of theta. And so that's going to be equal to, since this thing is sliding without friction, we'll be accelerating m times a. And so we're solving for a here, and we would divide both sides by m. So what you're left with is that a is equal to g sine theta. And that would be your